जय हिंद बच्चों. Today we will discuss application of determinates and matrices. We have already completed adjoint and inverse of a matrix, and today we will proceed towards the application of determinates and matrices, which is our actual target. Before starting the chapter matrices and determinates, this application is the actual target. You have already heard about consistent and inconsistent system in class 10. Consistent system means a system of equation is said to be consistent if the system and solution is unique. Otherwise, inconsistent, in this case, a system has no solution, or you can say does not exist. In first case, it may be unique or infinitely many solutions, but solution should exist. So that is consistent system. Now we will proceed to the solution of system of linear equation using inverse of a matrix. Okay, let us consider the system of equations a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to a3. Okay, let's take the matrix A is the matrix of coefficients a1 b1 c1, a2 b2 c2 and a3 b3 c3. Similarly, let takes x is equal to variable, matrix of variables x, y, z, and similarly b is the matrix of the term on the right hand side, that is b1 b2 b3. Then the system of equation can be written as like ax is equal to b. You can see if we multiply these two matrices, you will get the same result. A1x like row by column, a1x plus b1y plus c1z, like a2x plus b2y plus c2z. Now a3x plus b3y plus c3z is equal to d1 d2 d3, and then by equating the matrices you can write a1x plus b1y plus c1z is equal to d1, and similarly the other two equations. Okay, so now in this case ax is equal to b. Now multiplying both sides by A inverse. A inverse Ax is equal to A inverse into B. A inverse A, that means you know I into x, and here A inverse B. That means solution of the matrices, that is x, can be calculated as A inverse B. A inverse you know how to calculate. A inverse is adjoint A upon determinate A. You have done in the previous classes. Now into B, by the multiplication with B, you will get the matrix of variables, that is x, that will give you the solution of the pair of linear equations. Now this is the first case. Now in second case, if A is a singular matrix, in the first case A is a non-singular matrix. Non-singular matrix means determinate A is not equal to 0. Now another case, if A is a singular matrix, then determinate A is 0. In this case, we calculate adjoint A into B. If adjoint A into B does not equal to 0, that means numerator is not equal to 0, then solution does not exist, and the system of equations is called inconsistent. And the another case, in which the numerator, that means adjoint A dot B is equal to 0, then system may be either consistent or inconsistent according as the system have either infinitely many solution or no solution. Now let's continue. Let's take one example which I have written. X plus 2y is equal to 2 and 2x plus 3y is equal to 3. Now we will check the consistency of the solution. So first of all, write this in the matrix form. Then matrix of coefficients 1, 2, 2, 3, and matrix of variable, because it has only two variables x and y, is equal to matrix of these number 2, 3. That means Ax is equal to B, and if you multiply by A inverse, A inverse Ax is equal to B. Here say Ix is equal to B. Sorry, A inverse B. Here it is A inverse B. A inverse B, x is equal to A inverse B. This is the way to get the solution of this, and if you want to check the consistency, then get the determinant of A. That is 1, 2, 2, 3. Now its value is 3 minus 4, that is minus 1, which is not equal to 0. Because the determinant A is not equal to 0, so solution is inconsistent. Okay.